Hello, my name is Eric Freeland. I am doing a presentation on the four forces of flight for my Liberty University Aviation 220 class of the spring semester of 2020. Um, with this presentation, four forces, which are thrust, lift, drag, and weight. Now, all of these will work together with one another in certain ways in order to be able to fly the plane. Um, they will stay constant, and then they also will work against each other. So, in order to see this, the the best way to describe this is thrust is equal to drag, and lift is equal to the weight. And this is applied when the aircraft is in a constant or steady flight, meaning there's no changing with the aircraft. Everything is constant, steady going. Nothing is increasing or decreasing. It's staying the same. So in this type of situation, like when you're flying along and you're staying at a certain altitude, a certain speed, everything is equal to one another. And it is possible to have the thrust and drag equal, but the lift and weight not to equal, and vice versa with the thrust and drag not equaling, but lift and weight may equal. So looking at thrust versus drag, let's say you are on the runway and you're attempting to take off. The best way to do this, so that way you don't just sit still, you have to have your thrust, your forward motion. The forward motion is created by the thrust, and as you start to roll down the runway, your thrust is outweighing your drag. Therefore, your thrust is greater. The best way to describe this is as airspeed increases, the thrust will be greater than the drag. As airspeed decreases, the drag increases over the thrust. So for example, here we're looking at you're taking off to your rotation speed for a Cessna 172. You're starting at the back of the runway at 0 knots. To increase to 55 knots, your thrust has to be greater than that drag. When you're looking at weight versus lift, it's the same thing as the thrust versus drag. They are equal to each other inside that constant steady flight. In order for the aircraft to either gain altitude or to lower its altitude, depends on what you're trying to do. So if you're trying to, in this case, climb from 2,000 feet MSL to 4,000 feet MSL, your lift has to be greater than your weight. And then vice versa. If you're trying to descend from the 4,000 feet MSL to 2,000 feet MSL, then your weight is going to have to be greater than your lift. So constant flight, it works in several different ways. It's not just straight and level. While that is could be considered a constant flight, while you are level at a certain altitude, your thrust and drag come into play because you could be increasing or decreasing your speed. While also you could be in a constant flight while you're climbing or descending. If you set up yourself into a, say for example, a 500 foot per climb or 500 foot per minute climb or descent, then once you maintain that certain per minute drop or increase, then you are now considered constant, and that the lift and the weight is now equal with each other, and you just continue on this steady path downward or upwards, whichever you're trying to do. So this there are ways that this will be considered a constant flight while you are descending, increasing speed. It works the same way if you are in the climb out off your runway takeoff, where you are increasing your altitude and your airspeed is increasing, building that airspeed on your climb out. You can be considered constant if you set up a steady, constant rate of climb and then you're building that airspeed. But once you build that airspeed and you build that constant rate of climb, then everything is considered constant. You're in a constant flight. All forces are not equal with each other. So hopefully this helps you understand the 4 forces of flight and how it affects your aircraft as you fly. Thank you very much for watching the video.